So, thanks for coming. My name is Matteo. Today I'm going to speak about frontend, microservices, and front web and components. So, my name is Matteo, as I said. Here is where you can find me on Twitter, on GitHub, and a little bit everywhere. Please follow me. Give me your feedbacks about this talk, about what I speak about, or whatever. I want to interact with people, so please speak with me. So, who I am? I write software. I've been doing it for many years now. This is what I like to do. And occasionally I speak in conferences. I never do like very informative talks because I think that for me it's easier to speak about what I do. During this talk, I'm going to speak about a little bit about what I've been doing at work on the last couple of years. I'm going to tell you a little bit of my story about OpenTable, which is the company I work for. And I'm going to speak about some cultural problems we try to face when working on our huge front-end code base. So, to give you some background, so OpenTable is a company that basically focuses its business for developing software for restaurants. So, given that we have more than 30,000 restaurants in the world that are our clients, they run our software in their restaurant. We are able to, we have mobile applications, websites that allow users to instantly book and have a instantly confirmed reservation on the restaurant that is our client. We do other stuff. For example, we have almost 500,000 reviews per month that allow our data science team to analyze the data about our users and try to give to the user a better experience. And speaking about a little bit more technically, we have engineering departments in Europe, in London, especially, this is where I work. But we have also other engineering teams in North America, South America. We are based in San Francisco, India, and counting, many remotes everywhere. So we know that every time we write some code on the front end, our code is going to be executed by many millions of people after a couple of minutes. And the OpenTable.com website, which is the thing I'm going to talk about today, because obviously this is just one of the websites we work for. As said, we do other products for restaurants, etc. It's a project that involves more than 50 engineers. This is obviously probably quite common in many enterprise companies. The problem is it is not very easy. In our case, there are some little interesting facts. One is we are not on the same office. The 50 engineers that work on the same website are located in San Francisco, in LA, in London, in India. So when they work all together on the same code base, it's not easy because we need these people to work together. We need the business that are obviously some needs to be very close to engineers because we want to provide value. But how to do that? So it is very complicated. We tried many years ago to experiment and to try out ideas and approaches. And it took a couple of years to get where we are today. So to summarize, just to as an intro, I will say first, today we have a kind of a strange and unusual architecture for our website. So we have something that we call microsites. Microsites are what? A microsite is like one page, or maybe a couple of pages, that care about a very specific piece of domain logic. So, for example, in our website, if you go to OpenTable.com, you have an home page for like the San Francisco restaurants, and then you can click to a restaurant, you can see the restaurant profile, then you can perform a search, and you can book your table. So, in our situation, when you go to the home page, that's what we call start page. That's the start page from San Francisco, and that contains maybe San Francisco offers, some pieces of information for San Francisco, etc. What we do underneath is actually we have a front-end layer, which is kind of a routing application that translates a URL and decides to route the user and the request, the HTTP request, to a microsite. So a microsite is a single little unit of code that does one possibly very little thing and very well, and is owned by a specific team. A team that is composed usually by 2 to 3, 4 people maximum, and this team works very close with a product person. So it means that every time OpenTable needs to do some changes on the home page or on the search results page, there is a specific team that is composed by a very limited number of people that is able to speak directly with the product and try to release fast. So more in details, what happens really technically? So I do in my browser digit this URL. What happens is a couple of services detect that the user wants to navigate in the start microsite. And it detects that actually the user wants to go to the San Francisco Metro page. And this gets translated to a URL that looks like that. So it gets translated to an endpoint, which is a private endpoint inside our infrastructure, which is the start microsite. Some parameters are transported to the microsite. And we also have a service that directs this directly to an instance. So it serves a kind of as a load balancer, but also as a translator service for SEO-friendly URLs. So what happens if you are the start microsite? So first, you are a very small team. We believe in this because we tried many things. During this conference, I heard so many people speaking about how team dimension can influence how a company can deliver, how a company can be agile. In our situation, especially for the front end, we found out that that's a number that works very well. So how do we achieve that? First, these people are DevOps. So what is DevOps? DevOps means that these 2 to 4 people, when they basically get some acceptance criteria well defined with product, they write the code, they deploy the code. Obviously, they care about testing it. They care about putting it in production. They care about monitoring. They care about setting up the monitors and the pagers. And they get waken up at night if something is wrong. So these people care about the full life cycle of the software, from the creation to the testing to the deployment to the maintain phase. So how do you achieve that? Obviously, you need to have minimal complexity, and this is not very easy sometimes, but we try to do that with a microsite approach. To achieve usually complexity, what you need to allow people to deploy multiple times a day is to reduce your dependencies. And if you want to reduce your dependencies, sometimes it's not possible, but you can do something. You can actually make your contracts between you and your dependencies very clear. That helps basically communication. When a team in San Francisco depends on a team in London and there is a problem, more than likely one of the 2 is sleeping and one of the 2 is working. And if you have a problem, you actually need to think about the fact that you really need to wake up your colleague or not, because obviously we want to communicate well, but we also want to optimize these interactions. So a smaller code is also easier to test, because you need to test less things, and you are able to test more effectively. It is easy to maintain and is easier to extend. So basically, it's more resilient. This allows you to deploy more often, which is required by the business. And basically, we are speaking about ownership. So what is ownership for me? For me, ownership and in the DevOps world means we don't have anymore an ops department that basically deploys your application, or a QA team that QAs your application. You don't want that in a team of 2, because a team of 2 wants to deploy as soon as the feature is ready. And if you want to do it, you need to make the team of 2 able to deploy in a good way, obviously, and also to monitor your application very well. And basically, we are speaking about giving to the team the ownership and to own that code and to take care of it. So the microsite approach is interesting, but there is a single... so if you want, you can see the microsite as a first step when you speak about componentizing, for example, a huge monolithic code base, which is actually what happened to us. The second part is actually the smaller components. So what about the pieces of code that are shared between microsites? For example, in our case, the header or the search box that allow people to search things. in theory, you want the search microsite, for example, which is the search team, and the homepage team to be independent. You don't want them to go and say, can I deploy this? Can you deploy this? Or I depend on you for this. So, and also, you don't want everybody to duplicate all the logic and all the front-end parts. So how to do that? So we created a service for sharing the common parts. So this is an example of a request that can come to a search microsite. He has some information like, give me the tables for this city in this time. So the microsite is going to do his stuff. He's probably going to go to services. He's going to try to make a search. And then, before rendering, he's going to go to the components API. He's going to ask for the header. He's going to ask for the footer. He's going to ask for the common parts. And then he's going to render the page in a way that looks like that. We have something like a shared CSS component that comes from a main project that actually generates a style guide and also is useful for bringing some discipline on how we actually write our style and how we style things. This is useful because our design team worked very close with our front-end engineers to create a maintainable style guide. As a result, we have a component that creates a bundle and puts it there in every page. So the idea is you want an architecture to be super granular and underneath. But when the user goes from page to page and clicks, you want to make the user look like he's navigating to the same website. In this way, because we have actually some components that are composed by markup that is shared between page by page, actually you are giving to the user something like that, because the user is going to navigate to pages that have exactly the same markup for the header, for the head, and for the body. So how does this work? So let's imagine that the component needed is the header for our web page. So what happens is a microsite can ask the common UI elements API for the header. Something that does is actually to specify a version. So we have teams that own components. We have teams that own microsites, and they need to interact. So how can we do that? We thought, well, we can't remove this dependency if we want to be resilient and robust. We want to introduce a change in the header, and we don't want to ask 20 people to redeploy their microsite, the 20 microsite, because we made a change in a library. So if you have a tool like that, everybody makes a request for each request that receives, so we can make changes live in the header, and we can make changes live in the microsite, and everybody is kind of autonomous. We try to make this contract clear. So you have a component, we have a version. If you are a component developer, you use semantic versioning to actually specify if you are fixing something in a component, if you are breaking an API, so you push a new version, etc. Something we did, which is a little bit unusual on the front-end world when we speak about components, which is a word that people use for so many things, it's our components have logic. So if the header components maintainers need to own the header, it means that we wanted to make the contract clear for when do you need the header. You need the header for a specific city, you need the header for a specific language, you need an header for when user is logged in or logged out. So if we make the contract clear via an API, there is a parameter that specifies a user type. You provide me the user type, I am the header, I'm going to give you the header that you need, and you're just going to trust it. It means that we are actually creating a contract that is very easy to understand, is very easy to be established, and is going to improve the way the two parts actually communicate and work together. We use also API is REST, is JSON. We use headers for specifying other parameters. In this example, we want the header in English, but you can ask, you can make the same request for the Japanese, and you're going to get the header in Japanese. You're just going to put it there, and you're going to trust the header, because that is the team that owns the header, not you. So the response is going to look like something like that. You're going to get an HTML response. You're going to take that. You're going to put it there. And that's what you need to do. One thing you can notice here is the response is HTML. So in our code base, we have today in production something around 20 microsites for OpenTable.com. And those are owned by 6-7 teams, I think. And some are written in C#, some are written in Node.js, some are written in Node.js 4, some are written in CoffeeScript. And the idea is if you have a response that is actually pure HTML, That's fine, because everybody can run his server-side technology for running his web application, and it's going to be irrelevant if you want to put the header in a C# application or in a Node application. So, does this work? So it's been there in production for a couple of years now. We did a lot of iteration. We tried a lot of different things. What we achieved? So I think we achieved consistency. Today, what we can do is, I need to make a change in the footer. What we used to do 4 years ago with a huge monolith was, I'm going to make a change. I'm going to wait 2 weeks because we were releasing every 2 weeks. And then the change was everywhere. Now, how can you do it on the microsite world? Well, if you have a component, we make a change in the footer. Everybody is going to make a live request to the footer component. That's going to be live. So we can actually deliver pieces of functionalities directly in the website very easily. We have coordination. We don't need actually to ask anybody that owns a microsite to do something if we want to change something on a shared component, and vice versa. If someone wants to own a piece of functionality on the website, it's totally independent and doesn't need anybody else. We have optimal front-end loading. As said, the markup is shared between all the microsites. So underneath, a lot of stuff happens, but on the main level, it looks like the same website. It is easy, actually, to do microsites if you follow this model. After we used this approach to actually get away from our monolithic applications, we found out that it was easier to test new ideas and to just create a new team of a couple of people, assign them to a new microsite, add a new rule on the top. That was easy to test new ideas, maybe for specific markets, for new microsites. So, how does this work? So, this is a little bit of theory. How many of you write code? So how many of you want me to do a little live demo to understand how we do production deployment for components? Okay, so I'm going to try. So OpenComponents is a framework that we open sourced, which allows people to create and distribute components that are production ready, simply to use, simply to develop, simply to deploy. It is open source, so, and it is written in Node. So if you do npm install global OC, you're going to get a little CLI tool. Can you read the screen? There are some lights there. I can try to zoom in a little bit. Is it better? Yes? No? Yes? Okay. So if you do OC, you can see the CLI with some available commands. So something I want to do is I want to create a folder which is called Velocity Components. Oh, it exists. Okay, so I already created it, but it's empty. Okay, so I want to do a new component. OC init conference component. Do you know how the Jade view engine works? Yes, or you prefer handlebars? Handlebars. Yeah, let's gonna use handlebars, which is the default one. So this is gonna create a simple component, which is a folder, and I'm gonna show you how it looks. If I go here, I have a template. I have an optional server-side part, which is written in Node, and I have the description of the component. So let's try to make a test. I want to work on this component, so I'm gonna do OC dev. And this means I'm going to tell the framework to watch this folder for changes. Now I want to go to my component, and I want to do a component like this. I want to say, this is hello. And I want to say name. Then I go to the server part, and I provide a view model that is going to need for the component. So for example, I say name in JavaScript is context params name, and the default is going to be John. If I save this, my component is going to be on my browser. So let's go here. And actually, let's go here. Let's do a new tab. No, this is not readable. Let's go back here and let's try to switch. So if I do this, yes, readable. I can do. So basically what this does is it creates, on port 3030, it creates a registry of components that I can use locally to make experiments. If I do go to this URL, which is localhost here, I can see the components that are running like locally. I can see my conference component, I can see version 1, and I have a little tool that allows me to see the changes. If I want to play with this component, I can come here and I can see how it works. I actually can provide a parameter as well, and I can see name Matteo. I can refresh, and I can see how the component is going to look like. So this is a very simple component, but I want to show you something else. So now that I have my component, I want to tell people, I want to deploy my component. So what is this component? It's a component. Simple description. It has a version, it has some configuration, and I want to tell people how the API works. So I want to say that he accepts a name parameter. I want to say that this is not mandatory because he has a default. I want to say that it's a string. I want to say that, what is it? Is your name. And then I can say that example Jane. So now that I did this, I can stop my local development. And I want to deploy this. So now that I have my folder of components, I want to link this folder to a registry. So I do registry, add, and I connect a registry. I created a little registry that I use just for presentations. Qt.com. Nope. This is going to require internet, so finger crossed it's going to link the registry. This is just going to tell the folder, this is the registry that you need to care about. So in these steps, you can see how I can create a component. If maybe I'm a new hire, I just joined the company. This is quite easy to teach to a person. Now I know that this folder is linked to this registry, which is perhaps the OpenTable production registry. And I can do a C publish my component, which is called conference component. So what this does is actually he goes to the registry, he publishes this component for version 1.0.0, and he gives me back a URL. So this URL is now ready to be used and to be given to my consumers. So I can tell to people, now you can use this URL, and you can get my component for V1. And this is it. So you can see that if you make a request to this component, you can see an HTML response, which contains your component. Cool thing is, you can ask actually for the latest patch of a component, or maybe for the latest minor version of a component. And another thing is, if you go to the home page of the components, you can actually discover all the components that are available in a registry. Here is a lot of test components, but if you come here, you can see, no, I think this was another presentation component. I called it conference component. Here you can see the documentation automatically generated. You can see the parameters, and you have a sandbox. So what we have just done, so I created a component, I delegated to a registry and to a little framework the ownership of deploying it and making it production ready for me. And now I have the information that I need to get to another team and say, now you can reuse this. And the contract is, this is an API, this is the API, this is your requirements, this is how to use it. So how can someone consume this? So let's go back to the slides. How many of you are following me or are lost? A couple are lost. Oh, not so many. Okay, just one. Okay, so we have this. So how does it work? So we have a registry, as said, which is an HTTP API, and that is used for publishing or to retrieve components. Then we have a CLI, which is what I showed, which is a little tool that components creators, but basically component owners, can use to create and test, develop locally, and then publish components. And then we have consumers like microsites or websites or whoever that actually can use the registry to get this component. every time a component is published, the registry is going to do a lot of stuff, is going to run some tests, are going to take all the images or the static resources that are inside a component, is going to upload them to a CDN, is going to do all of that for me. And what I'm going to get is a URL that is usable from for other people. So I already did the demo. I think I needed to say that before. But yeah, so how you consume this component. So you can get to there, as I said. You can make an HTTP request. You can get a markup. And that's the easy one. But actually, we created something like a client-side rendering. So our components are, because the registry is publicly exposed, at least in one part, components are totally client-side renderable. So if you want to render a component, you can use pretty much the same structure using a little client that is 8 kilobytes that we created, and is actually, it works with all browsers like IE8, which is something that our business needed. And then you have basically a system that allows people to deliver pieces of HTML markups everywhere in a couple of seconds. The API is very similar. You basically have a URL, you can specify the version, you can specify the parameters even on the client side, and then the framework is gonna, when the page is gonna be loaded, render your component. You can do stuff like nesting components and other stuff that I'm not gonna talk about today. So if you work with the front end a little bit, probably you're gonna start thinking about, well, this is okay, but that's not great. Because if you have like a huge blob of markup, like rendered HTML that is maybe 40 kilobytes, maybe you have a view of 1 kilobyte and you have a one view model of 1 kilobyte, so that's not optimal. Actually, the client-side library, but if you run Node.js, you can do that on the server side as well, actually does a special request to the registry, and it gets the two parts separated. So you can get a component like that with a URL for your view, and just the data that composes the view model. It means that if you have 10 components in a page, you actually can cache the view because that's going to be semantic versioned and immutable. The framework never allows people to overwrite components. So because you have immutability, actually you have high cacheability. So rendering components 10 times in a page, or more probably in our case, going to 10 pages and re-rendering the header or the footer is going to take a little bit more on the first time if you do client-side rendering, but then it's going to be cached infinitely. Same for Node.js. So let's summarize the features. So we have a system that enables people to create new components independently. They have a framework that allows them to put them in production, and obviously they follow the right practices, right? They test their software. They deliver high-quality software. I mean, that's not something I don't have a magic wand for doing that. They need to be responsible. We have granular ownership because we have a specific owner for the component, a specific owner for the microsite, and you know what? If you think about this pattern, like we can extend it. We can say, if you are actually a microsite, you are developing a component that someone else needs, maybe you can create a component for that, and then you can share it with other microsites. So that's a pattern that quite works for us. Today, OpenComponents has been in production since January, is totally open sourced, if you want to have a look. And we have something around 40 components. We have like 5 or 6 components like the header and the footer, but all the other components are people that are just creating new stuff, creating new prototypes. And they can share pieces of code very easily with other teams. We have performances because you can do a lot of stuff that I'm not going to talk about today, but high cacheability for semantic version is an example. And we are robust. So if you have something like the microsite, and then you have a service on the server side that everybody depends on to actually render your page, what happens is if the components API goes down or is slow, the problem is we created an R dependency for all the microsites, and the microsite is not going to be able to render its page because the components API is not responding. But if we have isomorphism, so we have server-side rendering and client-side rendering, we can do something like, okay, I'm going to start rendering the search page, I'm going to get the header and the footer, but that's not responding in 500 milliseconds, or is timing out, or is responding with a non-200 response. I'm actually respond with the client-side rendering code, and I'm going to delegate to the client to try to retry to render the components. This means that if your business is based like us on making reservation, and you as microsite that owns the reservation flow depend on the components team, and somehow the business requires you to work, because that's how the company makes money. If your dependency, that is the components team, developed something that doesn't work, you can still return to the user with a page that maybe doesn't look nice, maybe it's going to have some spinners to say, I don't have an header, I don't have a footer, but actually you can click here and you can confirm your reservation. So the idea is we transformed an hard dependency to a weaker dependency because we offered a failover strategy. So the framework somehow cares a lot about empowering teams to reduce their dependencies and to simplify their contract. As said, a lot of people are now using it for doing A/B testing to try new ideas, new widgets in production. Microsites have control because of semantic version. What happens is if I rely on another team for a component and the component is always broken, maybe I'm going to consume version 1.2.3, and every time I deploy, I'm going to check because I don't want the component to break my stuff in production. Instead, if I trust it, I can say I'm consuming 1.x.x because I trust them, and if they don't break the API, they are going to do a good job, so I should trust to do this in production. So after that, so my conclusion, what is a microservice? Why microservice was in my title? So I have to be honest, for a long time, I thought that microservice was just another word. People say microservices and say usually, well, you have a very small domain, limited complexity, very simple things. So what's the difference between a service? I mean, a well-designed service should have the same characteristics, perhaps, right? Well, but you should work close, you should release fast, you should deploy quicker, and the microservice should be very small. Well, that's a good characteristic for a service anyway. And then I realized that perhaps the secret is not on the code. The secret is on the culture. So let's go back. What happens when I go to opentable.com and my browser receives that request? Well, as said, we have a service that translates the URL and redirects the request to a microsite. And then the microsite goes to the components, it gets what it wants, and then responds to the user. So what happens when product in OpenTable needs a change in a microsite? So product goes to the website and says, what is this? Oh, this is start. Okay, so this is start team. So I go to start team and say, can you do this change? Oh, this is us. Yes, we are going to do it. Or they say, no, this is actually a component. You can go there. They go there, which is a team of 2 people. They say, can we do this? Yes, we are going to do this. So what is similar here? So technologically speaking, we have a flow that is very well defined to redirect the user to a very small piece of code. But reality is, culturally, we have a team of 50 people that are organized in a very flat structure for working in team of 2, 3, 4 people to actually own a very small piece of software. So if our user wants to make a change in the header today at OpenTable, it needs to edit a piece of code that is around 100 kilobytes. 100 lines of code, which is a lot, but still something that a new hire that joined a couple of days ago was able to tackle in 1 hour of work, pairing with another senior engineer. And after 1 hour, it was deploying to production in the first week of work. So it means that in the first week of work, you get hired in a company and you are able to push stuff in production because you are working on such small unit of code that is understandable. And if you don't understand it, you can rebuild it. If you need something similar, you can rebuild in a couple of days 100 lines of code to do what you want, and you get your component, and you can get it. So this talk really opened my mind. If you know Greg Young, you should try to have a look at this talk, because it totally opened my mind. So how many of you optimize their software to be highly maintainable? Right? We want that. Not so much, actually. Come on, a little bit more. How many of you optimize the test to be their software to be well tested and right? So how many of you optimize their code to be easily destroyable? Not so many. So the idea is, how much time do you need? Someone do this. So how much time do you need to rebuild 100 lines of code? Not so much. The idea is, what if someone that works on those one line of the code leaves the company because he's been hired by another company, and another person needs to tackle that? If he doesn't understand that code, he can just rewrite it. It's 100 lines of code. So it is actually possible to destroy it. The problem is, well, but it's not just that. You build the code and then you need to test it, you need to deploy it, you need to duplicate all of this work. Well, that's the secret. If you want to do microservices or microsite or microsoftware or maybe micro teams, the reality is you need to embrace the DevOps culture. It means that your team needs to stop thinking about, I write my software and then I'm done. You need to test it, and you need to deploy it, and you need to monitor it. If you know how to do that, then you can write other units of code, and you can build frameworks like OpenComponents to empower teams to share components and code and reduce dependencies. And that's probably the secret of microservices. So microservices, or let's say microsites, or let's say micro teams. I never heard about the micro teams word, by the way. So if in 1 year we are going to have a lot of teams talks about micro teams, I invented this word. So, so you want minimal dependencies, right? So that's probably the secret. If you have a lot of dependencies, that's not going to work. And if you have dependencies, try to make weaker dependencies, designed for failure. Minimal complexity, so less code, smaller code, modularized, perhaps, depending on the technology you use. You can write little modules, little libraries, and ship them. You can work closer to business. I think that when people say, I'm going to work on a microservice and I'm going to design, I'm going to get to the business requirements, should be ready in 2 months. Well, that's not a microservice. If probably you are going to need 1 week to build it and to get it done, that's kind of a microservice. But if you need 3 weeks, it means that if you want to work on that code with another person after those 3 weeks, that person is not going to need 1 day to understand that code. Because if someone needed 3 weeks to build it, it means that the other person is going to need another week to learn the code and perhaps to get up to speed, etc. So that's not a microservice, perhaps. Ownership. Ownership is not just a buzzword. You need to care about it. It means that you need to care about quality, and you need to trust people. If you care about quality as a company, you hire good people, and you care a lot about hiring the right people. If you hire the right people, you trust these people, and if you trust these people, you give them power to be independent, and to be, you trust them to deploy to production when they need, and you trust them because they will care about their software, and they will wake up at night when they need. But obviously, they will design their software in order to be prepared and to avoid that, because nobody likes to wake up at night because your stuff is broken, right? So you need to be optimized for resilience. When the business needs something to be done, you can't say, I'm going to do it in months, because the business needs something immediately. So if you optimize your code to be small and you organize your team to own very small pieces of that code, you're going to be better, because you're going to be able to redirect your business requirement to the right people, and maybe that's the key. I don't know if it works. For us, it is working, and I think we need more of this on the front end too. So conclusions are, SOA is not about code, it's about culture, I think. It is easy to implement some technical changes to our code, but there are consequences on the way we work together. We need to communicate well, we need to work well with the people around us, and we need to be working very close to business as engineers. If we don't do it, that's not going to work. And the secret for me is every time you do a change, that's going to have a cultural consequence, and you need to readapt the way you work. And then probably you're going to readapt your code again, and that's going to be an infinite cycle. And that's the way for me to be agile. Test. If you don't test stuff, everything I spoke about doesn't make sense, because I spoke about powerful tools that allow people to do potentially very bad things. So if you don't care about quality, that's not going to work anyway, at least in a big corporation. And then design for failure. If you design for day one, saying that when your dependencies are around you, maybe the designing, the idea is you depend on people and you can change that. But if you design your software to be resilient and robust when the other dependencies are not working or not available, you're going to be good, because it's always good to have a plan B. And then let's componentize all the web. Components are what? Are Angular components, React components, OpenComponents. The idea is front-end is becoming very complex, and if we start componentizing the front-end in such a way that we can work on more complex things, the web is going to be a better place. So, thank you.